Hello class, today I'm going to show you a little bit more details about explicit dynamics, how to use the explicit material with more information. Okay, let's open Workbench. Basically, for this workshop, I'm going to use already drawn geometry, and instead of using general materials we had, or even nonlinear materials, which they have a little bit more information about plastic deformation and so on, I'm going to use explicit materials, which they have much more data in it. Okay, now it's time to import the already prepared project. So I go File, Import, and use this file, which is oblique impact file. It is going to tell me first you need to save the project and then start importing something. So I'm going to save it inside AP11. This one is going to be number 4. Now I can import. File, import, oblique impact. Now everything is inside. The first step is going to including the material. Remember, we use a lot general materials and nonlinear materials. Now I'm going to use, where are they? Explicit materials. Explicit materials are going to have more information about the relation between yield stress and temperature, yield stress and velocity and impact, those kind of things, which is we are going to have more complete information about the material we are selecting. So I'm going to click over explicit material. It takes a bit longer time than the other types to load because the amount of information we have is much larger. So wait for it to load. Okay, here I have all the data. I'm going to look for cart brass. CC cart brass, the first one. So let's add it to our library. The second one is going to be lead, lead here. Rubber, rubber. And steel 4340. Steel 4340, all here. Let's close data. As you can see, we have all the general information we need: density, specific heat, shear modulus, bulk modulus, and also here we have Johnson-Cook strength. If I open inside, you can see the thermal softening exponent. So basically, we are going to have plastic strain because of the temperature and how yield stress changing, about hardening, and depends on the dynamic we are going to have. We can use these information. So this information are going to be very useful for our simulations. Let's open model. Geometry is already loaded. Let's see. Okay, this is our geometry. As you can see, we have 2 plates with 4 bolts. They're attached to each other. And let's open. We have some rubber spacers between. These are the rubber spacers. We have steel washers between the bolt and the metal sheets, and this is our bullet. The outside, the shell of the bullet is going to be cut brass, and the inside is going to be lead to have a little bit weight for it. And as you can see, this we are simulating half of the this geometry. So we're supposed to have um, symmetry. Okay, let's assign the material, plate. So this is going to be rubber up to this. Let me assign rubber for this. These are, this is going to be steel plate. Oh, so let's go for steel 4340, steel washer, and even bolts are going to be our steel 4340. But for bullet, I need to select. I want to select. Okay, now let's select the outside. The shell is going to be cart brass, and the inside one is going to be lead. Okay, these are the information we have. Model, geometry. Okay. Let's check a few of them to make sure. This is my bullet. Bullet had two parts. The core is not assigned. The core is supposed to be lead, and the case supposed to be brass. Oh, bolt is supposed to be steel. This bolt steel, steel, steel. Okay, let me check everything based on material. So the blue one is going to be rubber, so the middle rubbers are, the material is rubber. Lead is going to be green, which is the inside, the core of the bullet. The cart is going to be lucky reddish, which is for bullet case, and the rest is yellowish and steel. So no problem, we are happy with it. Okay, let's close the geometry. You can see we have symmetry, so we are simulating half of it. We already talked for dynamics, we don't need, for this case, any contacts, so I can just delete this one, and automatically it's going to recognize body interaction. Let's go with default mesh, and I'm going to check if it's too much or not, and then make it a little bit better for our license. So it's too much. I'm going to decrease the number of mesh for bolts. So let's select this, control this, even is washers. So sizing, let's go with 8 and generate the mesh. Okay, a little bit larger. And then I have an extra coordinate here at the tip, so I want to add the sizing there. So that point, and it is going to automatically understand that I'm looking for a sphere of influence. Let's go with, for example, 40, and the size, let's go for example 4, and see what is the quality. Meshing is not be okay. Let's see why it didn't apply to update. Let's go with name selection and select the plane. This time it is going to understand, and sphere center is going to be at the XZ plane we already defined. And let's go with 4. Now hopefully this time it is going to work. Okay, much better. But yeah, I need to decrease to, for example, 2. Yeah, now it's good. Let me check the number we have, 9,000. Hmm, I can go a little bit, for example, 1.5. Let's see how many it is going to. Okay, 10,000. I'm happy with the size, and it's in our license limit. And let's go continue with this workshop. So initial condition, we are supposed to give a select the geometry for the whole bullet. It is going to move, let me change the unit to meter, for example 500 meter per second. So it's a bullet, it's very fast, and the direction, let's select this line and apply. So I can see the direction. Oh, okay, so I can put negative here, so it is going to be at the direction toward to the plates we have. Okay. Okay, we took care of velocity. Let's go analysis setting. We need to tell ANSYS how long it's necessary to simulate. Let's go with very small number. And if it wasn't enough or it was too long later, I can change it. Also, let's edit some of the stuff here. For erosion control, I can turn on material failure. Currently it's no. I can make it yes. So whenever after this collision and when this bullet hit these two plates, it is going to pass through it, and the material or the elements in contact with this bullet, the stress is going to increase till reaching yield stress. If it reached yield stress, I'm asking by this option uh, that element is failure for me. So just remove it. Consider as a particle because it reached the yield stress, drop it, drop that element. Regarding output, 20 is very small number, so I'm going to have 200 outputs. And basically, I want to have very smooth video of the bullet hitting uh, these plates and passing through, and how materials are moving around. Okay, I'm happy. Let's solve it, and later we can assign some solutions to that. This is going to take so overall it took almost 3 minutes, and we are ready for solutions. Let's go and check total deformation, stress, and evaluate those results. Let's use the frames available because I selected to have 200 outputs. So automatically when I select results set, it is going to select those 200 frames I already asked. So let's watch the video. Okay, let deform, but didn't pass, and we have a little bit of failure. Those dots are the elements failed, and ANSYS remove them. Let's see for deformation. Okay, now let's increase the velocity from 500 meter per second to 600, and I would like to see if I can if this bullet can pass through this two layers of steel or not. Let's go. Okay, let's see what is going to happen with the new update. This time we waited 3 minutes, 3.6 minutes. Yep, now we have some broken part even. Let's see our video. And we can see now we can see the hole created. Now, yeah, stress increases, then we have a lot of failure elements, and a piece of bullet shell stuck here, and the rest passes through. Let's see from the bottom side. Did you see when the hole started? Oh, let me take it a bit higher. See, now we have getting thinner, thinner, and then disappear. Thinner, 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 disappear, because I turned on, if we had a failure, just get rid of the element. Okay. You can change other options, play with the different parameters, and see the effect on the simulation. Thank you very much. See you next time with another interesting simulation.